the first weekly tests for the semester has actually been done fairly well. Clearly, there are people or guys of you in the class who have been studying already at this stage, and that reflects in how you answer these questions. This is pretty much textbook stuff. The first question, which is imine formation, that was the one thing that you had to write down there. This functional group, the general name for it is an imine, and that was 1 mark for that. To go and just read up about this chemistry, page 230 in the second edition of the Claydon textbook is where you need to read up about this. And there's a lot of intricate things in terms of this this reaction. But essentially, the first step is lone pair of electrons of the amine attacking the ketone, and we generate. And this is an equilibrium, all of this is an equilibrium, and we generate this hemiaminal, so minus there, N, 2 H's, and 3 carbons, and the methyl group over there. So we generate this hemiaminal, positive charge on the nitrogen, and then that just does a proton transfer to give the formal hemiaminal. So OH, NH, and right. Okay, so this is a hemiaminal, and the next step requires the acid. The acid is important now, and you can read that up in your textbook. In fact, too much acid will protonate this amine over here, and this first step won't be happening. So the acid is important to change the OH over here into a good leaving group. It's an acid-base type reaction, so and an OH2, so now we've made that into water, which is a good leaving group. And got the rest over here, and then the lone pair of electrons on the nitrogen are the ones that are going to kick in, and we kick out the water that way. And of course, we're almost there, not exactly finished, because we have a nitrogen with that on, but we also have that last hydrogen remaining, which can leave by being picked up by the solvent, either the ethanol. There's a whole lot more ethanol, so that's probably going to pick it up, but we also have some water that has been released, and that can pick it up as well. But it's okay just to leave it like that, and that gives our product, and that would have been the 5 marks. The ranking the bases was the interesting one. For me, what was quite interesting is number 1 has to be the least basic of all of these. They're all bases except for water. Water is the defining point of not being a base. Water is a neutral molecule. In fact, the whole pH scale is based on the fact that water is neutral, and we have a pH of 7. So it can't be basic. It is the least basic of all of these things and must be number 1. The rest then fall into line in terms of the relative basicities that we'd spoken about. And I mentioned to you, these are 2 strong bases, but the alkyl anions, or the carbanions, are definitely the most strongest of the lot. And LDA over here, or lithium diisopropyl amide. Okay, LDA. That one is not as strong as this one, which is tertiary butyl lithium. I'm just writing the shortened version of that. And then we have an amine and an alkoxide. Alkoxides are definitely more basic than amines. Amines are very, very weak bases, generally speaking. So this one would have been number 2, and this is number 3. Okay, so moving down, we've got water, Hünig's base, then lithium methoxide, LDA, and tertiary butyl lithium over there. And then finally, this is just one of these things which is just a learning process. There are 2 methods that we could have used here. The one that I would have thought is the most appropriate would have been by adding TMS chloride, okay, chlorotrimethylsilane, TMS chloride, in the presence of triethylamine, an amine base. You could have used Unix base. There are a lot of tertiary amine bases that you could have used in this reaction. We just triethylamine is just such a common one that we tend to use it. Had you used Unix base, it would have been fine as well. The solvent tends to be dichloromethane. If you'd used THF, that would have been as fine as well. And this tends to be done at room temperature. Okay, this is a classic go-to reagent set for making these kinds of systems. And of course, the functional group, the name of that is a silyl enol ether. Okay, so this would have gotten you the 3 marks. There is another method you could have used, and we do need to discuss the implications of this. Just let me go back to this. Is note that this is all in one pot, all right? One pot, this is not done in a stepwise fashion. Everything is mixed together in one pot, so the reaction kind of proceeds very smoothly at room temperature over a period of minutes and hours. Okay, so this over here, however, the other method we can do is we first generate the enolate using a very strong base. So we push the equilibrium all the way over. So step 1 is adding something like LDA, and this must be at minus 78 degrees Celsius in the presence of solvents such as THF. Once we have fully generated the enolate, we can then add TMS chloride and allow this reaction to warm up to room temperature. But in both of these things, we have to avoid any acid, okay? Acid, water, anything like that, big no-no, because these are very sensitive groups, okay? We can isolate them, we can work with them, but we've got to keep acid away because they will hydrolyze back to the ketone very, very easily.